So, you've done it. You've built this amazing AI model and it works perfectly in the lab. But here's the thing. Getting it out of the lab and into the real world, that is one of the biggest challenges in AI today. We're going to break down that whole journey from a controlled experiment to a live production reality.
Right, so you've trained the model, your accuracy is through the roof, the predictions are just spot on. But that's really just the starting line. The real question, the one that turns a cool side project into a seriously valuable product, is exactly this. Now what do you do?
Because, let's be honest, the gap between your laptop and a system that has to serve millions of people is absolutely massive. It's a journey filled with complexity, with risk, and with about 1 million things that can go wrong. This is the real heart of what we call MLOps, or machine learning operations. Okay, so before we even dream of hitting that launch button, we have to get our model ready for the trip. And I'm not just talking about accuracy here. We're talking about building something that's truly robust, something you can trust, something that's ready for all the chaos of the real world. A really solid production-ready model has a few key hallmarks. First, you've got to have detailed experiment tracking, so you know exactly how it was made. Second, it needs to survive some tough peer reviews to catch any hidden problems. And third, and this one is so important, it has to be reproducible. Anyone else on your team should be able to take your work and get the exact same model with the exact same performance. No magic, just science. All right, our model is forged and ready. Now it's time for the launch. And you should really think about this next part like a rocket launch sequence. It's this totally automated, super high-stakes process where every single step has to be perfect for a successful deployment. And that launch sequence? It has a name, CI/CD for machine learning. CI/CD stands for continuous integration and continuous deployment. Basically, it's an automated pipeline that grabs our model and pushes it through a whole series of quality checks before any user ever gets to see it. This little piece of code right here, this is the blueprint for that pipeline. It's our automated checklist. It defines every single step, from testing and security scans all the way to the final deployment and turning on the monitoring. You see, nothing is left to chance. So let's actually follow the model on its journey. First up, it hits automated quality and performance tests. If it passes, boom, it gets scanned for security holes. Then it gets packaged up and pushed to a central library called an artifact registry. Next up is a super important test flight, a canary deployment, and we'll talk more about that in a sec. If the canary flies, it gets promoted to full production. If it doesn't, the system automatically rolls everything back. And finally, all the observability tools get switched on. So what on earth is a canary deployment? Well, it's a strategy where you release the new model to just a tiny fraction of your users, like maybe 1%, and you watch it like a hawk. It's our canary in the coal mine. If it does well, great. We slowly roll it out to more and more people. This is totally different from a blue-green deployment, where you flip a switch and all the traffic goes to a new environment at once. The canary approach lets us test in the real world with almost no risk. T-0, we have liftoff. The launch was a success, our model is live, and it's serving real users. But listen, the mission is far from over. You could actually say the most critical phase is just beginning. This is life in production, where we have to constantly keep an eye on its health and performance. You know, the single biggest threat to any live model is something called model drift. Think about it. The world is always changing. The data your model sees today might look very different from the data it was trained on months ago. And when that happens, its predictions start to get worse. This is the silent killer of AI systems. So, to fight off model drift and other problems, we have to monitor a few vital signs. We're watching for changes in the data and the core ideas the model learned. We're tracking technical stuff like how fast it responds and how many errors it makes. We're on the lookout for security threats or people trying to abuse the system. And of course, we're keeping an eye on the business side of things, making sure we meet our performance promises, our SLOs, and that we're not blowing the budget. And all of this brings us to what might be the most important lesson here. These stages we've talked about, development, deployment, monitoring, it's not a straight line from start to finish. Deployment is not the destination. It's a continuous, never-ending loop. The MLOps journey is really a circle. We develop and we rigorously review a model. We use a slick, automated pipeline to get it out there safely. We watch it relentlessly while it's in production. And all the things we learn from that monitoring, that feeds right back into developing the next, even better version of the model. And then, the whole cycle just starts all over again. Which kind of leaves us with one last big idea to chew on. An AI model is really just a snapshot of the world at the exact moment it was trained. So in a world like ours that is constantly changing, constantly evolving, can we ever really say that an AI model is truly finished?